Hello friends, welcome to the Boolean Brain. In continuation to LeetCode Daily Challenge series, where we are solving the daily LeetCode challenge right from intuition to implementation. So we are on day 30, where we are going to solve today's LeetCode challenge. The title says minimum cost to convert string to. So this seems to be the continuation to yesterday's LeetCode challenge, which was minimum cost to convert string 1. Okay, so let us see what's the difference in part 2. So we are given a two zero index strings, source and target, both of length n and consisting of lowercase English characters. You are also given two zero index string arrays, original and changed, and an integer array cost, where cost of I represents the cost of converting the string original of I to original of changed of j I. So you start with string source, and in one operation you pick a substring x from the string and change it to y at cost of z. So if there exists any index j such that the cost of j exactly equals to z and original of j exactly equal to x and change of j equals to y, you are allowed to do any number of operations. But, but any pair of operations must satisfy either of these two conditions. The conditions are substrings which we pick in the operation from source A to B and source C to D with either B less than C or D less than A. In other words, it is ensuring that the indices picked in both operations are basically disjoint. Okay, we cannot overlap. The substrings picked in the operations A to B and C to D with A exactly equals to C and B exactly equal to D. In other words, indices picked in both operations are identical. Okay, so we have to return the minimum cost to convert the string source to string target using any number of operations. If it is impossible to convert, return -1. Okay, the problem statement is very similar to yesterday's problem statement, except yesterday the original and the changed array consisted of only characters. For example, this one. So this is example of yesterday's problem. But today's problem statement not only converts a single character, it contains a set of characters, that is strings. So we have given a strings which original which contains some string, and those strings can be entirely converted to the strings in that changed with this cost. Okay, so this is how the change in today's problem statement. Let us take a look at um, constraints as well. The source and target length are less than equals to 1000, which is less. Apart from that, yeah, the cost of I is reaching to 10 power 6. Okay, cool. So rest of the constraints look same, looks good. But if you remember in yesterday's problem statement, we solved the yesterday's problem statement using Dijkstra's, right? So we used the Dijkstra's. We could have used Floyd Warshall as well as Dijkstra's, but we use Dijkstra's for solving the yesterday's problem statement. Why? Because it was clearly mentioned that it each there was only a single character. The combination consisted of four single characters, right? So that's the reason at max 26 such were existed. So we simply created Dijkstra's for 26 characters, and then we were able to solve the problem statement. But today's problem statement is a bit challenging, right? So, because it involves strings, so we have to somehow figure out a way without going into brute force and running out of time. We have to find a way to match all possible substrings as well, right? So, match all possible substrings. For now, just try to identify what's the issue and we will figure out how to solve it later on. Okay, so uh, first of all, we should understand we have to match all possible substrings. Okay, cool. What else? But this is the sub part. The main problem is we have to convert source to target. Okay, convert source to target in minimum cost. Okay, cool. And while doing so, we have to find the minimum cost, right? So if you remember, yesterday we treated each character, since A was supposed to convert into uh, A and B was converted into C, we simply we assumed each character as a node, we assume each character as a node, and we created a graph, right? We created a graph like A pointing to A, similarly A pointing to yeah, similarly B pointing to C, and so on. So this is how created a graph yesterday, but we cannot created a graph of single character now. We need to care because our replacement our replacement has changed to strings, so we need to create these strings. So these are part of our graph now. So for example, in this 1, 2, 3, 4, 5, 6. So these six basically convert or become a part of our graph. So we have to build a graph on these six nodes. Okay, that is fine. So in order to find the minimum target, we first build a graph of these nodes and find all pair shortest path. Why I'm finding all pair shortest path? Because while optimization, while checking, I need to ensure I will have two entities, source and target substring. So I need to find out if that what is the difference between the shortest path between source and destination. So I build a graph and I find out all pair shortest path using Floyd Warshall algo. Okay, so this Floyd Warshall algorithm is a very simple algorithm used for finding all pair shortest path. So if you are not aware of this, it's a very simple. I will try to explain, but I would recommend to go and watch a separate video on this because that will help you to understand this. So ultimately, our problem statement reduces to Floyd Warshall plus finding this substring. So how will we find the substrings in minimum way, right? It contains a lot of possibilities. Since we want to deal with substring BCD, so we have to find, let's say for example, we are here. So A converted to A, that is fine, but now we want to find, now B is not matching to C, right? So we have to check if BC is matching to CD. Even for matching, first BC and CD needs to be present in the graph. These 1, 2, 3, 4, 5, 6. This each string from original and changed will become a part of graph, and I have to check if the substring that I'm associating with, if that exists in this. If yes, then only I should be able to compare because that only makes sense, correct? So that's the reason. So I have to do this optimally for all the strings. So for that I need to use DP. Okay, DP on string. So that this is how it's definitely a hard problem. Hard problem when you are not aware of this, but once you get a hang of it, once you are able to understand the individual concepts of light version, how to apply it in a graph, and how to apply DP on strings, right? Then this problem statement becomes simple and easier. Now let us take a look at the code. Okay, cool. Now, yeah, so this is the starting point where we are given the source string, a target string, an original and a changed vector, and similarly a cost vector associated to each string conversion from original to changed. Now, what we will do, we will first map all the relevant strings to some unique IDs. Why we are doing that, you will be able to understand it in coming time. For now, just think of this like we are working on original and working on change. For each string in original and changed, we will assign a value to it. So we initially assign ID counter to 0 and just keep on iterating if that for each string, if that string exists in this string to ID, it's a map of a string to integer. So this string holds the string value and this holds some unique ID. So I want to give a unique ID to each integer. Why? You will come to know later on. For now, just think like we are tagging the integer to each unique string. Okay, cool. Now I want to initialize the distance matrix for Floyd Warshall. So as you might recall, Floyd Warshall works in Floyd Warshall. If there are m number of nodes, we declare a m by m size distance matrix, and then we keep on iterating m number of times for on the m by m matrix, and at the end we the each ij value corresponding in the distance will give you the value. Okay, cool. So that's how I declare a 2D vector of distance of size m and m by m, and initially assigned to infinity because I don't know if the path exists, right? So I simply mark all at infinity. Infinity is declared here. Cool. Now I start iterating on the uh, original this vector, and at each point, I figure out the source and the original of ayat and or change of ayat. What is the because I'm definitely sure that that this BCD can be converted to CD, right? So I'm aware of this. So so I simply fetch out the ID first because this will give me the ID. Original of I will give me the string, and this string to ID will give me the ID because now you might remember I converted to unique IDs because this is where it will help me to operate as an integers, right? So this is one node and U to V. So I simply update the value of distance from U to V because that is the one which I am given. So this cost is given to me, right? I want to update that cost. So I simply update the distance of U to V with the current distance, which was earlier uh, assigned as infinity, and minimum of either the existing or the current cost of I. Why cost of I? Because this is the value that is associated for converting original of I to change of I. Okay, now my initialization of Floyd Warshall matrix is completed. Now, this is the simple Floyd Warshall uh, three loop logic to find out all pair shortest path. So, if you're new, this might sound a little difficult, but once you are aware of this concept, you will be able to understand it very quickly. So, we have to do uh, the m number of iterations, where m basically stands for total number of nodes, and nodes is and this m is nothing but total number of elements. String id dot size. String id is containing each unique element between original and changed, because my graph is now being built on these six elements. So BCD, FGH, THH, CDE, THH, and GHH. So these six elements, right? So my value of m is now 6, and I have to basically do six number of iterations in order to find all possible uh, shortest path between all pairs. So I simply have a loop starting from 0 to 6, and I have this other loop ij for updating each cell in the distance. I initially check if distance of ij is equals to infinity. I just continue. Otherwise, at each point, I try to update the ijth value by trying to have a path through k. K is nothing but the kth node. So that's how ij is broken down into I to k and k to j. So ij is broken down to ik and kj. So at each point we try to update use by choosing the minimum element from the existing one. I try to check if the value will be minimum by keeping the minimum or updating it with distance of kj, ik and kj. Okay, so this logic is part of Floyd Warshall. Cool. Now we have the Floyd Warshall ready, and we now the distance is now updated with the minimum between any 2 points. Okay, cool. Now once this is done, I have to now work on the DP. I will explain this in a minute. I want to work on the DP. So what is DP now? Because I want to work on this source string, right? So if I want to work on this source string, I I declared another DP of size n+1 for ensuring one based. So this DP of n, if you remember, n is nothing but length of source. So my dp of I will give me the answer, which is the minimum value to convert the first I elements. So if I get a, in order to convert the first two elements, my dp of 2 would give me the answer. dp of 3 will give me diff3. So I start from 0 and at each point I'll try to update it. Okay. Now all the logic will try to make sense. Now keep just following with me. Now so this is the loop for the DP. So yeah, this is the loop for DP, and at the end I'm returning DP of n. Okay. So first condition is the base condition, which seems if the DP of I is infinite. What does it mean? We are initially storing the DP of we are starting from 0 equals to 0, so this condition won't uh, trigger. We check if source of I is nothing but a, and target of I target of I is also nothing but a. So these two are matching, right? So this is the ideal case. Since the characters are already matching, do we incur any extra cost? No. At that point, I'm storing in the one based, right? So dp of for 0, I'm storing in 1. So dp of 1 will be updated to minimum of I+1. I+1 was initially value infinity. So infinity or dp of I. What was I? Ith value was basically 0. So I incurred a cost of 0. So this infinity in the I+1 position got updated to 0, which is like this 0, comma 0. Okay. Why I got the answer 0? Because these two characters were matching. Now, next other option. So if my source and these two are not matching, now I need to check, and uh, I need to have a loop on all possible lengths starting. So if I'm here, I need to check length 1, length 2, length 3, and then 4, right? So these substrings I need to check. So how will I check? I iterate on all lengths. So if you remember, we had declared a length. So this length is nothing but a vector. Sorry, I mistakenly submitted it. So this length is a vector where I'm iterating on the map, and I just simply pushing the length. I need to have all the lengths of the elements from this original and changed. So what is the length of this? What is the length of this? So all such lengths, I push it in lengths. I sort them by ascending order, and then I erase the duplicate elements. So that this is how the duplicate elements will be erased, and I will be continuing with only the unique lengths of the nodes. Okay, cool. Now for each length, so for example, in this case, uh, length is 1, right? So for 1, I will check if I plus length is greater than n. If it is going greater than the length of source, this is out of bounds, so I simply break. Otherwise, I break the substring. I form a substring starting from I to length for the source as well as the target, and I check if the source and the sub source and the sub target exist in the string to ID. Right? You recall we created the string to ID. This count function will simply ensure that key exists. So I want to ensure this because whatever the substring that I'm forming, I need to ensure if this is part of original or changed, right? Then only able to I should be able to form a pair or have other logic on it. Other if that value itself doesn't exist, then it doesn't make sense. Correct? So I simply figure out. Now you recall we had stored the indexes like substring. This is given some vertex. So this is given some vertex. So I want to convert this source to destination. So assign them into u and v, and I check the distance between u to v. If the distance is not infinity, then I will try to update the DP. How the DP will be updated now? Let's say the length was of 3. So I simply directly jumped from 1 to 3 by adding the length into the DP, and the value will be updated in a way the current position, the value of the current place, or or dp of I plus the distance between u to v, because we are directly having a combined jump of these many elements character of length characters. So we simply update that using distance of u comma v. Cool. Once this loop happens entirely for all the length of n, at the end, we will check if my dp of n was fulfilled with some value. If that value was not fulfilled, it will be infinity, and that in that case, I'll simply return -1. Or if the value less than infinity exists, then we'll simply return the value which is present at that n position. Okay, cool. So I hope um, the approach how we approach to finalizing the logic and how we came up with the code. I hope it is clear to you. If you have any doubts or queries, do let me know in the comments. And if you're new to the channel, please consider subscribing. This really helps me motivate. Okay, cool. So yeah, I hope everything is covered. And uh, if you have any doubts or queries, please do let me know. Thank you.